Hello there. I just thought I'd give you a little bit of an update to let you know what's been happening and what's going to be happening between now and Christmas. Well, over the last 3 weeks we've had probably about 10 inches of rain, and we've had quite a bit of problem with flooding around the property, so I've been digging ditches, not making too much videos because it's been, not very good here. But over that period of time, I've been receiving some of the new parts for the new build for the new CNC router, which I will show you in a minute or two. I just move things around in here a little bit as well, and I'll just take the camera and handhold it and just show you what I've been doing. Okay, so I've given the little mini CNC router a bit of a permanent home in this area on this bench now, and I think I'd like to use it from there for the time being anyway, because I just wanted it really out of the way off the main workshop bench because I need to use it. Of course, a lot of you know, I think I might have mentioned that the big laser's gone, and I will be doing some more work. In actual fact, I came up here to start a new video with the fiber laser. A number of people have asked me about engraving into stainless steel, so I'm just going to do another quick video on that. But this is the thing that's going to interest most of you guys, I think, and that is the parts I've been receiving for the new AMAX CNC router. So I'll just put this camera back on the tripod and show you some bits and pieces. Okay, so now I'm in front of the camera again. I'm probably going to make a video of this for general release on my channel as well. So you're going to get to see a little bit of how I make a video, I suppose. So I'll sort of show you, or I'll leave it uncut or unedited for you guys, and it'll be drastically edited for public release, because I do tend to make a lot of stuff up, and things like chicken cluckings, I try to edit them out as much as I can. I'm probably going to have to go and chase that one away, actually. There's some of the neighbours' hens actually that come over on our property. We've got our own hens, but no, I'll have to go and stop the camera a minute and go and chase this one off. Okay, we're back. So here we go. Hello there, and welcome to my workshop. Now today I'm just going to be unpacking some of these items that I've received for my new CNC router build, which I've dubbed as AMAX, for want of a better word. So the first thing we're going to start with is what I've received from Stepper Online. I'll bring you in for a closer look. So what a lot of people don't understand is when you move the camera in for, a better look, you have to adjust all the lighting, because I have been trying to get the lighting a lot better than what it has been. So that means, am I off camera? Yes, I am. getting other lights. Like this. Just to backlight it, a little bit, but try and keep the lights out of the camera, which is sometimes you can. Okay. Yeah, these are LED there. I think they're a total of 40 watts, something like that. So it's not main lighting. The ones I use for main lighting, they're equivalent to, I think they are equivalent to like 250 watts each. The ones behind the camera at the moment are probably 500 watts or more equivalent. That's why I'm showing a little bit whiter. They're LED. I'll just turn the camera around. These, I do a mixture of LED and quartz halogen, and of course the ordinary shop lights. And then I adjust the colouring with filters in the editing program, so it tends to look a little bit better. Anyway, okay, so back to the general public. So I'll move this in. Sorry if I'm moving you around a bit and making you feel a little ill. Okay, so here we go. Okay, so inside here, I always use Stepper Online, and they always sort of fully protect their equipment, and they're very, very well packed, as you can see, and very reliable equipment. So there's 3 of these. That's the 3 of those. Plenty of padding. Now this is a high output power supply, or power switching unit, from AC to DC. If I can get it out. There we go. Beautiful. I'm going 36 volt with this particular build, and this is a 11 amp power supply, which is more than enough for the stepper motors that I'm using. Put that back in. Okay. Oh, look at that. Isn't that nice? All very, very well packed. Now these are the highest performance and output NEMA 23s. Okay. See along there? And look at the size of the shaft. This is a D shaft. Okay, a D shaft being there's a slight flat on the shaft there. Okay, to allow you to tighten up on. High torque output. These particular ones are, I think they're the highest torque output NEMA 23s, and I'm pretty sure, yeah, they're 3 Newton meters. It actually says on the back here. and they're 4.2 amp. Okay, so you know, way more twist than what I actually need. Okay, so there's 3 of those going on. When I built the MIDI CNC router, which is the small benchtop one, I bought a what is known as an offline controller, and I've had a lot of success with it. You know, not a problem at all. No glitches. So I thought, well, I'm going to get another one. So, which is what I've done. And here it is. From the same supplier. But because this is an updated model, so this is the new model of SMC controller. And this is the 5 axes hand controller with a mag mount on the back, which plugs into the unit. And this is the actual unit, as I'm sure a lot of you now will recognise. So let's take it out and have a look. Look at that! That's absolutely beautiful. So this is it. The SMC5/5/N/N. Don't know what the other numbers mean. I just call it a SMC 5-axis controller. And I can tell you now, it is the best bang for your buck to operate a CNC machine, whether it be a CNC router or a milling machine, or lathe for that matter. You know, this is my what I would suggest to go for. Because all the other controllers, you know, which rely on a PC or a laptop, you know, it's getting expensive now. You know, if you want to run a Windows 10, you're going to go for something like Mac 4. And by the time you know, if you're building your own unit, the Mac 4 CAD, what's known as the breakout board or smooth stepper, I've got one over here. Okay, this is a Mac 4. If I can get him out. That's the driver for Mac 4. And this is a Mac 4 smooth stepper board. You know, lovely. This is $450. So that's before you start. So then you've got to buy the program and the license for the program, which is another, I think these days it's nearly $300. So that's the program and the CAD taken care of. But then you've got to have, you know, a Windows 10 computer lying around that you're not using. because you shouldn't use it for anything else other than your router. Definitely not connected to, the internet, because you only need a little glitch and your CNC router or your mill is going to take off and do something you don't want it to do. Best you're going to snap tools off or ruin the work that you're doing, or you could end up taking your damn fingers off. So, never have it connected to the internet if you're using a PC. And I'm sort of moving away from these. I think I always will use either Mach 3 or Mach 4. It's a good program. I've used it for probably 15 years now. So, I'm not totally bagging it or anything like that, because it served me really well. But for these days, I can get this and the hand controller for $450 delivered. And it will do everything Mach 4 will do, or Mach 3. And, on my other one, I've run 1 million lines of code in one job, which ran for over 5 hours. No problem at all. Did it without thinking. It's got a 8 gig built-in memory, which is bigger than anything you'd need. I don't keep files within the unit myself. It's got a USB port here that you plug a flash drive in, and I get this to read the file off the flash drive. Like I say, it works very, very well. Never a moment's problem. And all the connections are on the back here, and I will do a dedicated video, a more in-depth video on this build of building the electronic pack, wiring it up together, and wiring this up and setting this up. I touched on it on the last build I did, making one of these, with one of these rather. But a lot of you I'm asking for more detailed information, and so I will go into depth with it. Okay, so that is the controller. Incidentally, I will say that, I will tell you that I am not associated with the manufacturer or the sellers of these. I paid for this one. Okay, so now down to some of the hardware. Oh, look at that. 20mm linear round rail bearing blocks, or linear bearings. So there's 4 of those. Beautiful, beautiful. I've elected to make this CNC router. Incidentally, it's going to be, the table is going to be about just under 3 feet by 3 feet operational area. These are a meter long, but you know, you lose a bit by, you know, the distance of whatever these are. You know, you have 2 of these on here like this, and can you see? You have 2 of these and they're separated, so whatever this distance is here, you're going to lose that in its movement. Alright, so just say I'm going to lose, say, about 150 millimeters, for example, which is about 6 inches. Okay, so it's going to be that much less, okay, in the operation of the axes, but that's okay. I was just after something smaller than the larger one that I made a few months ago, and bigger than the first one that I made. So this is halfway in between them, and you know, I'm going to be happy with that, I think. And also I went to linear round rails because I find, for a CNC router anyway, the linear square rails for a, you know, sort of a semi-professional use of a CNC router, it's probably a little overkill. If you're going to build a CNC milling machine from scratch, if you weren't going to use the, you know, the dovetail ways, you'd need to go square linear rails, probably 1 inch. But for, you know, medium work, linear round rails are fine, I have found. Okay, so that's those. So I've got, let me see, I've got 2 sets of these. So it's going, you know, the y-axis and the x-axis are going to be the same length and with the same, you know, the same gauge, which is 20 millimeter. Okay, so these are the 16 mil round rail bearings. And these are 16 mil rails. And this is for the Z. They're 400 millimeter long. I like a, you know, fairly good length on these. Perfect. So, very well made. And a beautiful ball race and screw. Just check that they sent the right one. Yep, 16 mil. So I'm running 16 mil for what these are is 16 by Just check that it's right. Yep. So these are 1605s, which means the diameter of the screw is 16 millimeter and the pitch is 5 millimeters. So every one revolution, this will progress 5 millimeters in each direction, which is very, very easy for. Look, there's no need to really do any calculation at all for the the steps of the stepper motor. It's done by measurement, okay? You sort of you get to know, well, you can do a quick calculation to find out how many turns you need to go in this case, because it's metric, 25.4 millimeters, which is an inch. And how many pulses or steps for each revolution. Okay, it's very, it's easy to get a quick calculation for that. But it's all done with a DTI gauge on the actual axes, and you ask the controller to move 10 millimeters, 50 millimeters, whatever you want. And when it moves and you register with a DTI exactly what it's excuse me, exactly what it's moved, you compensate on the steps that you put into the controller, right? Whether you need to give it more or less. And that's the easy way of doing it. You don't have to do there's no big complex working out really. Okay? And I'll show you how to do all that when the time comes, which is going to be about 6 weeks from now. So these are all okay. I'll show you some of the other bits now. The only item that is missing from this collection of bits and pieces is, of course, the spindle and water pump and bracketry and the VFD, which is coming in a single package, but at the moment it's stuck with FedEx in Singapore somewhere. It's been there for 4 days, so I should get it over the next week. So now we'll go on to the metal materials that makes the router chassis and gantry and what have you. So just swing the camera a little bit. So I've got an assortment of steel here. This is 150 by 6 mil steel flat bar. Also got 5 millimeter by 50 millimeter angle iron, and I've also got an assortment of flat bar that I might use to make brackets and what have you. Now I'll bring you down here for the aluminium. So I have an assortment of aluminium. Now this is actually, aluminium prices have doubled in less than 12 months. The aluminium that you see on here is approximately $400 worth. The steel is about $200 worth. So altogether here, just the raw materials is $600 worth. And also, this is a box of assorted fasteners that I've bought. 8 mil, 6 mil cap screw bolts and nuts. And there's still more that I'm going to need to go in it that I've actually already got. But that, you know, that's $100. They're just nuts and bolts. So they're not a cheap item to make if you're going to do a decent job. Altogether, there is, you know, this whole process is going to cost maybe just a little over $2,500. But it's going to be a very, very solid unit. It's going to work very well. It's going to work hard, and you know, to get something of this caliber imported, and you've got to be very, very careful importing these days, because quite honestly, with you, the 95% of the Chinese manufacturers don't meet European, American and Australian standards, and you can get a fine for importing it, so just be warned. So what we've got here is 12mm, all right, which is not far off ½ inch, all right, by 180, I believe. Hang on. $160. So what we have here is 12mm by 160. All right, so it's nearly ½ inch thick. Aluminium flat bar. Basically, I'm going to make the gantry, most of the gantry uprights, and the cross member that goes underneath the bed. All right, so I'm building this one quite differently. Now, for the gantry itself, I have a piece of it's let me see, it's nearly an inch. It's 25mm thick. Okay, and that is 180mm in width, and I've got about 1.5 meters of that coming, and that's cast aluminium, and it's been machined flat. In fact, that's where it is now, is being machined flat, because I couldn't do it on my mill that I have. There is 1 inch by 2 inch flat bar, 2 meters of it, and this is 12mm by 100, so it's nearly ½ inch by 4 inches. Okay, so that's going to be like the front and the back main chassis section. This is going to be the chassis section that runs in between, and the linear rails are going to be mounted on this for the Y. I have some more 12 by 100, and I've got some angle iron, and this is my, this is quite heavy gauge aluminium tube. Now what I do with this, I make the standoffs for the stepper motors out of this, and it does a really, really good job. So this is what I use. So if you're thinking of making your own CNC router and you want to do a decent job, and this particular one is approximately 3 feet by 3 feet working area, and it's going to be very solid, you're looking at about $2,500. So it is, you know, if you're going to throw some money at a project, you want to build yourself, you know, it's you know, you don't get something for nothing these days, you know. And building something like this too, you want as new material as you can, dead flat, and good quality. This is 60, I think it's 6061 grade. It could be 6060, but I think it's 6061. So there we are. And as usual, all the plans and purchasing information of whatever I paid for these and the vendors, all that information will be on Patron as soon as I've got it all drawn up. It's normally at close to the end of neighbours mowing the damn lawn over there now, I think. I think you can still hear me all right. So normally I get the plans up on Patron and all the, I can get the information up soon, a little sooner than that, for all the you know, the electronics and what have you. But it's normally towards the end of the build, and this build is going to take me, well, I hope to have it up and running before Christmas. So, and that, you know, all depends on the weather as well, because we're having a bit of a wet time. So, okay. Oh, one more piece here. There's some more flat aluminium bar. This is 10mm, and this is going to be holding our plate material to mount the spindle housing on for the Z-axis. So you know, never chuck your offcuts out, because they always come in handy for something. Okay, so I should be starting the build this, maybe not this coming weekend, but during next week I'm going to start building and filming, and make a bit of a start and get the chassis made anyway. So if you've liked this video, please like and subscribe, and also if you would like to consider becoming a patron to the channel, because it is the patrons behind this channel that makes it all work, that allows me to make videos and put, you know, sort of fairly decent, I hope, content out there for you guys to learn how to do this sort of thing yourself. And it's the patrons that allow me to do this. So please consider becoming a patron, and I'll see you all on the next video. So thank you for watching, and it's bye for now. So that is how I film a video. In actual fact, you know, things like neighbours, although they're 100 meters away, you know, they still have, you know, tractor mowers, you know, sort of 30 horse tractor mowers to do their lawn. Of course, when they come up to the fence, you can hear it in here. Things like that happen, and birds and parrots, and you know, I don't mind parrots, but they squawk and interrupt and what have you. And of course, the weather. It gets quite blowy here, and of course when it rains you can't film, because all you get is shh on the roof. But anyway, can't complain. It's still a very, very beautiful area to live. You may not know, but I live just outside a city called Hobart in Tasmania. Now, Tasmania is a large island off the south coast of Australia. It is still part of Australia, but there's not that many people here. I think there's only there's something like just over 500,000 people live on the island, but this island is the size of England, so there's not many people here really. So it's nice and quiet. And of course, in between all this, I've had to stop and have lunch and all this sort of thing. And this whole process of making this video has taken probably, not too bad actually, this one, about 2.5 hours. It's a very quick one actually. Normally I am filming for between 8 and 10 hours, you know. What ends up being like a 12-minute or 15-minute video, you know, is filmed over, you know, sort of up to a 12-hour period. And sometimes, you know, this goes over 2 days. I'll split it up, you know, so 4 or 5 hours one day, 4 or 5 hours the next. So, yeah. So I hope you've liked this video, and you know, I'll do so. I do plan actually to do a lot more on Patron and become a lot more involved. And if you ask questions, a lot of the times, a lot of the questions you do ask, it is easier for me to make a video about it and publish the video. Like one of the guys there has asked me about a spindle, a VFD. Well, I have touched on the subject in several videos, but with this particular build, I'm going to go right into it and show you where to put every single wire and why. Okay? And how to you know, hook it up to, in this case it's going to be to the new SMC, but I will also explain how to connect it up to a, you know, smooth stepper board for Mach 3 or Mach 4. Alright then, so better close this to, better bring this to a close now, and I'll say cheerio for now, and thank you guys for being there. So bye for now.